Our topic for today is biochemistry. And the thing about biochemistry is that this is going to be the first in a series of videos talking about how chemistry underpins all the mechanisms that make biology work. And so we're going to be talking about how chemistry kind of helps make biology happen. I'm going to have a series of videos that I'm going to display on different slides, and those are going to be linked in the description of the YouTube channel video, so you can go watch those. So the first thing that we need to talk about is atoms. Atoms are the basic unit of matter, and when we are talking about something being the basic unit of something, we mean that it's the smallest functional part. So atoms are the smallest thing that function as matter. You can have things smaller than an atom, and we're going to talk about those, but they don't function like matter. This is the same kind of situation when we talk about the basic unit of life being the cell. You can have things smaller than a cell. Atoms, for example, are smaller than a cell, but they don't function as a living thing. And everything that we see, like any pieces of furniture or any living things that you see, all of those things are made up of atoms. There are two areas or regions in an atom. There's the nucleus and there's the electron cloud. The nucleus is where we find the protons and neutrons, and the electron cloud is where we find the electrons. So speaking of protons, neutrons, and electrons, those are the three parts that make up an atom. And so protons and neutrons are found in the nucleus. Protons have a positive charge. Neutrons are neutral. And then electrons are found in the electron cloud, and they have a negative charge. And the protons attract the electrons. So generally in a base atom where nothing has happened, we see the same number of protons and electrons. Protons are really important. The number of protons dictates the atomic number of an element, and that determines what the element actually is. And if we change the number of protons, we change the atomic number, we change the element we're talking about. And when it changes the number of the protons, we also change its placement on the periodic table. The periodic table is the way we arrange elements, and it's a guide for us to kind of figure out some different aspects of elements. The man who created the first periodic table was Dmitri Mendeleev, and he's a really fascinating man, and I have a video here about him that you might want to go watch. And he's the first man who's credited with developing a periodic table. So we have atoms. What happens when we kind of put them together? What happens when we link them together? We form compounds. Another word for this is molecules. These terms are slightly different and they have slightly different meanings in chemistry, but for our purposes, we're going to use them interchangeably. So compounds and molecules are when different atoms of different molecules are bonded together. So there are two types of ways to make compounds. There's an ionic bond, and the ionic bond is where we have the electrons moving between the two elements. And we have sodium here. And when you look at sodium's electron arrangement, that's these blue dots here on these rings, you notice that it has this one lonely electron out here. And it's going to decide that it doesn't want to stick around. It's going to want to move because it doesn't like being alone. So it's going to move over here to chloride. And if you notice, chloride has these lovely pairs, except right here, it's missing one. And that's where that electron's going to come in. It's going to move to that new element. And that's how ionic bonds are formed. The electrons move, and then the charge, the overall charge on the element is now different. And this is because the protons and the electrons are no longer balanced. They're no longer the same. Remember, we talked about electrons and protons being the same number in a base atom. But now this electron's moved, and so now we have more protons than we have electrons in the sodium ion, and we have more electrons than we have protons in this chlorine ion. The other form of bonds is covalent bonds. And this is where the electrons get shared between the two elements. And if you look at all of my examples here, when the elements come together, they're going to share those electrons and they're going to be found between the two nuclei. So you can see that with the two hydrogens, they're sharing their two electrons right here. The fluorine, they're sharing them right here. Oxygen and carbon, you can see all of those electrons get shared just between the two nuclei. And so this is kind of how you tell the difference between covalent and ionic. Ionic, the electrons are moving and forming ions that have opposite charges, and those kind of attract each other like a bar magnet, versus covalent bonds where they're sharing the electrons. And that's kind of where we're going to leave off today's notes. We're going to stop here after we've discussed bonds, and we're going to pick up our next topics in the next videos.